I want to talk about the idea of measurement systems now. And measurement systems are very useful. It wouldn't make a lot of sense just to have kind of one unit to measure an attribute. For example, length. Let's say we picked the meter as our one attribute. Then if we wanted to measure something like the thickness of a hair or something, how would you express that in meters? It would be very difficult. Or if we want to express, say, the distance from the Earth to the Sun in meters, again, the numbers would get very large, so it would be very difficult. So the idea of measurement systems is you have some units, but the units have comparisons between them. So it tells you how to convert from one unit to the other. So here are two examples. We're just talking about length here in the first one. So here's our measurement system. It has to do, this is the imperial one that's found in the States for the most part. And four of the units are inches, feet, yards, and miles. So we have one, and we just have to kind of pick one that's our basis for our measurement system, and we base the others off that. Well, a foot, what is a foot? Well, there's a rule, and it says that 12 inches is the same as 1 foot. So it's the same thing. 1 foot and 12 inches are the same length. And a yard is equal to 3 feet. And finally, 1 mile is equal to 1,760 yards. We could do the same thing, say, with volume, so with liters. So here we'll have the liter as our central unit, as the one we're basing all the others off of. I use the small L for liters. Sometimes you can use a capital L for liters as well. In fact, I will do that in an example a little farther on in this video. But liters here. Then we have a centiliter. And what's the relationship between a liter and a centiliter? Well, 1 liter is 100 centiliters. And a milliliter, well, the relationship between liters and milliliters is 1 liter is 1,000 milliliters. And again, there's a little bit of a difference between the first example and the second example. In the first example, I have the rule based off the one before it. Here, I have the rule based off kind of our central unit entirely. Both are totally acceptable and totally fine. And finally, we have this kiloliter here. What's a kiloliter? Well, 1 kiloliter is 1,000 liters. So there are measurement systems here. And just as a little reminder, in any sort of metric system, so we're talking about liters or meters or grams or anything like that, there are 3 usual prefixes that come up. We have kilo, which means 1,000, centi, which means 100th, and milli, which means 1,000th. So you can think, well, how many centimeters are in 1 meter? There are 100 centimeters in 1 meter. So 1 centimeter is 100th of a meter. 1 millimeter is 1,000th of a meter. A kilometer is 1,000 meters, for example. But these are the 3 prefixes that you guys should know. These come up all of the time. And then some exercises you might see. They might give you some kind of fictitious measurement systems, but the same ideas will apply. They will tell you some base unit, and they will tell you some relationships between the other units and your base unit, and it would just operate the same way. So a central thing that you want to do with units is you really want to express quantities in units that you desire. So the ability to change units from one unit to another is very important. And the whole idea, in some sense, we're multiplying by 1, but in a clever way that allows us to change units from the old units to the new units. And we'll do a little example here to kind of give you an idea of what I mean. And I want to express 756 inches in the unit of yards. How many yards are in 756 inches? So what we're going to do is we're going to write down 756 inches. And I need the units here. This is very important. Now, what I'm going to do, I know that 12 inches is 1 foot, and I know 3 feet is 1 yard. So my idea here is I'm going to go from inches to feet, because I know that conversion, and then I know the conversion from feet to yards. So that's the idea. There's lots of ways of doing this conversion, but I'm going to show you a way that kind of works for every type of problem, so you don't have to think about whether you need to multiply or divide too much. The whole idea is that you want to multiply by these unit fractions that I'm going to express here. So these guys will be called unit fractions. And the whole idea is, in this case, I know that 12 inches equals 1 foot. So if I write 1 foot over 12 inches, well, if we think about this, remember 12 inches equals 1 foot, so the numerator and denominator of this fraction equal. So this is just like multiplying by 1. But it lets me change my units from inches to feet. If you look here, I have inches in kind of the numerator of this number. You can think of it, if you like, as 756 inches over 1. But just like with canceling out common factors, I can cancel units. So if I cancel units, then what I'm left with here is 756 times 1 foot, so that'll be feet, and in the bottom, I have 1 times 12, so I end up with 756 feet over 12, and that'll let me convert to feet. But I can do this again to convert to yards. I can string these together. Now that I've converted from inches to feet, I can convert from feet to yards. And I know that 3 feet equals 1 yard. I'm going to put the unit I don't want in the opposite place from the unit I have. So I'll put feet in the denominator here, so it'll cancel out, and yard up top. And I know 3 feet is the same as 1 yard. And now the feet in the numerator cancel with the feet in the denominator. And I'm left with, if I multiply all of this out now, I have 756 times 1 times 1, and the unit that's left up top is a yard. So that's 756 yards over 1 times 12 times 3, which is 36. And you can check, if you do a little long division, you can check that 756 divided by 36 is indeed 21. So this is the same as 21 yards. So 756 inches is the same as 21 yards. Now, what did we do in that last example? So we did kind of 4 different steps. The first thing we did is we determined what units we have, the starting units, and what units we wanted, the ending units. We started with inches, we ended with yards. The second thing we did is we determined, well, let's come up with a chain of unit fractions to get us there. We knew how to convert from inches to feet, and then we knew how to convert from feet to yards. So that's our chain of units to get us there, and we can write these conversions as unit fractions. And then once we have that, once we did that, the next thing we did is we canceled off the units in the top and bottom until we were just left with the units that we wanted. So we wanted to convert the whole chain to 1 unit factor. I have this written incorrectly, sorry guys. It says vector, but it should be, I'll write it here in blue so you know what I'm changing, factor. Sorry about that. Convert chain to 1 unit factor by canceling units and multiplying the measures. And then finally at the end, we had the units we wanted. We just needed to do a little multiplication or division to obtain the quantity in our new units. So let's do this example here. How many seconds are in 22 years? Okay, so we're starting with years. So the whole idea, we know that there are, and we're going to assume here that by years, I mean just a regular 365-day year, not a leap year or anything like that. So we know how many days are in a year, so we can convert from years to days. We know how many hours are in a day, so we can convert to hours. We know how many minutes are in an hour, so we convert to minutes. And we know how many seconds are in a minute, so we can convert to seconds. So that's going to be our chain. So we start with 22 years. And we need to go from year to day. So we're going to put year in the denominator and day in the numerator. The easiest way to think about it is years start off in the numerator, and I want to cancel them out, so they go in the other place. They go in the denominator. So days go in the numerator. And we all know that 1 year is the same as 365 days. Again, ignoring leap years and leap seconds, just the usual 1 year is 365 days. So we've done this conversion. Let's go from day to hour. So we want to put day in the denominator and hour in the numerator. 1 day is the same as 24 hours. We've done that conversion. Now let's go from hours to minutes. 1 hour is 60 minutes. And then finally, let's go to seconds. We want to get rid of minutes, so we put minutes in the denominator and seconds in the numerator. And of course, 60 seconds is 1 minute. And again, note that the quantities in the top and bottom are the same, just expressed in different units. Okay, let's cancel off our units. Years cancel off with years. Days cancel off with days. Hours cancel off with hours. And minutes cancel off with minutes. And we're just left with seconds. So that's good. That's what we wanted. So we multiply this out, so it's going to be, I'll write it out in one long thing first. 22 times 365 times 24 times 60 times 60. And that is, of course, in seconds, because that is our unit that is left. And if you do work this out, you get 693,792,000 seconds. Excellent. And I forgot to put my check marks here, but we did go from hour to minute and minute to second. All right. So sometimes units are expressed as rates. So a common one, and the one that we're going to deal with, is speed. Kilometers per hour is a very common way of expressing speed. In sciences, meters per second is usually the common units to express speed in. So maybe we want to convert for whatever reason. And the whole idea with converting, we want to convert each unit, meters and seconds, separately to kilometers and hours. We can all do it in one line, but we want to kind of do it separately and then do our multiplication. And I'll talk about this in the next example. But if needed, you can flip units by taking the reciprocal. And what do I mean by this? Well, let's say if something was traveling 2 meters every second, well, I can convert this to seconds per meter. If it's going 2 meters a second, well, how many seconds does it take per meter of distance traveled? Well, if you think about it, here is our 2 meters, let's say, and all that takes 1 second. Then how many seconds have elapsed after we've traveled 1 meter? Here's 1 meter here. How many seconds is that? Well, of course, that is half a second. So you're just taking the reciprocal or flipping both your unit and the quantity of it. So this is the same as 1/2 seconds per meter. Okay, that'll come up in the next example. But for this example, we want to convert from meters per second to kilometers per hour. So let's do it. So we want to convert 30 meters per second. Let's convert meters first. We want to go from meters to kilometers. That'll be pretty easy. We know that conversion right off the top of our head. There are 1,000 meters in 1 kilometer. Okay, so let's multiply by our unit fraction. Again, we want to get rid of meters, so meters is going to go down on the bottom, and we want to be in kilometers, so it goes on top. And the unit that we're getting rid of course, goes in the opposite place from where it is already. Okay, and we know that 1 kilometer is the same as 1,000 meters. Remember, that's what this prefix kilo means. It means 1,000. So 1,000 meters is 1 kilometer. Okay. So we've done that one. We've converted from meters to kilometers. Very easy. Now we would need to convert from seconds to hours. And again, we know how to do this. We just have to go through minutes. So we know we can convert from seconds to minutes quite easily. There are 60 seconds in a minute. And we know how to convert from minutes to hours. There are 60 minutes in an hour. So let's go ahead and do it. So here, this is a little different because the unit that we start with is seconds. We want to get rid of this. It's already in the denominator. So we're going to put seconds in the numerator this time because it's in the opposite location. And that's what we want to get rid of. We want to convert 2 minutes first. We know there are 60 seconds in 1 minute. Okay, so we did that conversion. Let's put a little check mark there. Now we need to convert from minutes to hours. Same idea, where we already have converted 2 minutes, so we need to convert to hours now. So I want minutes up top because that's what I want to get rid of. And I want to end up in hours. So there we go. And we know 1 hour is 60 minutes. And now let's cancel off our units to make sure that this makes sense. So meters goes. We're left with kilometers. So we're going to have kilometers at the end. That's excellent. Now let's do our denominator units. So seconds cancels with seconds, and then minutes cancels with minutes, and we're left with hours. So we're left with kilometers per hour. That's great. So now I just multiply everything. So this is 30 times 60 times 60 over 1,000, and my units are kilometers per hour. And you can check very quickly, if you'd like, that this simplifies to 108 kilometers per hour. So really all we have to do is multiply 3 times 6 times 6, since this is 3 times 10 times 6 times 10 times 6 times 10. So we have 3 factors of 10 here, and each factor of 10 is going to cancel out with a factor of 10 in 1,000, and then we're just left with 108 hours. If you've ever gone car shopping, and you're reading around doing your research, you might find that fuel efficiency is given in 2 different units depending on the nationality of the medium that you're reading. So if you're reading, say, a US website, they will give their fuel efficiency units as miles per gallon, which is, of course, a distance per a volume. Gallon is a measure of liquid, and a volume of liquid, I should say. So it's distance per volume, whereas Canadian fuel efficiency is given in liters per 100 kilometers. And this is the opposite. This is volume per distance. So note that. So this is distance per volume, and this is volume per distance. So what we're going to have to do is we're going to have to flip our unit in the first one to make it become a volume over distant unit, which is what we're looking for. We're given that the fuel efficiency of a car we're looking at is 41 miles per gallon. We want to compare it to some other cars which we have measurements in liters per hectokilometers, or you might see it as liters per 100 kilometers. So we need to convert miles per gallon to liters per 100 kilometers. So maybe I'll let you guys try this. So pause the video now and see if you can come up with the answer. So remember, you're going to have to flip this, and then you're going to have to convert from miles to kilometers, or hectokilometers, I should say, and from liters to gallons. And I should give you one more conversion, actually. I should tell you that 1 mile is 1.618 roughly kilometers. So pause the video now and give this a try. Okay, let's set this up. So we want to flip our unit here. So rather than 41 miles per gallon, I'm going to express it as 1 over 41 gallons per mile, since I want to have our starting unit and our ending unit have the same type of unit. So this is distance over volume, this is volume over distance. I want to end in volume over distance, so I better flip this to be volume over distance. So we have 1 over 41 gallons per mile. So let's convert from gallons to liters. First, we know, we're given, that 1 gallon is 3.785 liters. So I'm going to multiply this by, we want to get rid of gallons, so 1 gallon down the bottom, and 3.785 liters up top. So I've converted from gallons to liters. That's great. We went from gal to L, and that's the only conversion we needed to get from our starting unit to our ending unit, at least just in the volume bit. So that one's not too bad. Now we want to convert from miles to hectokilometers. So we know that a mile is 1.618 kilometers, so I know how to convert to kilometers. And I know how to convert from kilometers to hectokilometers. So let's go ahead and do that. So we're going to have to chain these together. Okay. So I have miles in my denominator now, so I'm going to put miles in my numerator. And in my denominator goes kilometers. And I know 1 mile is 1.618 kilometers. So I did that conversion. And then finally, I need to convert to hectokilometers. So I want hectokilometers in the denominator and kilometers in the numerator, since it'll cancel out with this kilometers in the denominator. They will cancel. And I know that 1 hectokilometer, oh, wrong color here, 1 hectokilometer is 100 kilometers. Okay, so now let's cancel our units, make sure everything makes sense. Gallons cancels with gallons. We're left with liters. Good, so that's great. And then we have miles cancels with miles, kilometers cancels with kilometers, and we're left with hectokilometers. So our units that are left are liters per hectokilometer, and that's what we're looking for. Looks like we did our conversion correctly. We just have to do the cleaning up in terms of the multiplication here. So we have 1 times 3.785 times 1 times 100. So I can just multiply these. If I'm multiplying 3.785 by 100, I'm just moving the decimal place over 2 places. So this is like 378.5. And in my denominator, well, this one's a little more complicated, but I have 41 times 1.618, which ends up being 66.338. And our units, of course, were liters per hectokilometer. And I better simplify this to one number, so I'll do a little division here. And you get to, let's say, 3 decimal places, 5.706 liters per hectokilometer. And that's how to convert from miles per gallon to liters per 100 kilometers.